So this is a Calc 1 Test 2 review discussion. And you can see our first question on the computer screen there is, explain why the derivative with respect to x of k is 0, but the derivative with respect to x of kx is k. So how do we answer that? What's our key idea here? What do we want to think about? We're thinking about slope. If I have a constant function, let's say f of x equals 3, what does a constant function look like? Looks like this. F of x equals 3, f of x equals -2, f of x equals 7. They're all horizontal lines. And the slope of a horizontal line is 0. We think about cross-country skiing. If you're cross-country skiing, the hill is not giving you any speed. Your speed, your velocity is 0 if you are skiing on a horizontal sort of slope on a field. Whereas over here, what is the slope of kx? We recognize from what? We recognize from algebra that y equals mx plus b is the equation of a line. So if I have kx, y equals kx plus 0, what are we going to say? We're going to say the slope is k. And we know what? What do we know? We know that the derivative represents slope. So in this case, the slope of the tangent is always equal to k. So that's what I want you to think about. If you go back to our first test, we kept talking about slopes of tangents. That was our big idea that we're working with there. So in terms of the derivative of a constant function is 0 because the slope is always 0. And the derivative of kx is k. If I have a situation like this, right, kx plus -2 would be there. Kx would actually go through 0. The slope here would be k. So that's our key idea here, is thinking about slopes, All right, let's take a look at what we have. Looks like we're having some people having issues with audio. I'm not sure what's happening there. You're welcome to take notes as we are working, and I will post this on YouTube when we're finished. Right, pulling up our second question. Use the rules of derivatives to determine these things. So let's look at it. What do I have first? I have f of x is 7x cubed minus 5x squared plus 9x minus 1, and I want to find f prime of x. So this is our next question. What are we going to say to that? Well, the derivative of the sum is the sum of the derivatives. So f prime of x is the derivative of the first piece minus the derivative of the second piece plus the derivative of the third piece minus the derivative of the last piece. So I have the derivative of 7x cubed minus the derivative of 5x squared plus the derivative of 9x minus 1. You can pull the 3 out in front 3 times the derivative of x cubed. Pull the 5 out in front 5 times the derivative of x squared. Derivative of 9x. Derivative of 9x. What is the slope of 9x? As we said in our first example, slope of 9x is 9, but the slope of 0, the constant function, is just 0. All right. And now we can use our power rule. What are we going to say? F prime of x is 3 times, pull the 3 down, 3x squared minus 5 times 2x plus 9 minus 0.
I think you meant
F prime
to
of
put
x
7.
Is 9x squared minus 10x plus 9. Sophia, are you saying something?
Yeah, I think you meant to put 7 in front of the first derivative.
Oh, I miscopied it. I sure did. Let's call that a 7. 7. So 7 times 3 would be what? Would be 21. Thank you for the correction. So f prime of x is 21 x squared minus 10x plus 9. Yes, indeed. Pulling the 7 out in front is what I needed to do, and I just had a mental lapse there. So that's fixed. So that's our first derivative of that function. Let's go ahead and take a look at the next one that we have. I have the second derivative of 4 over x squared. So how do we do that? Second derivative. And I really don't want to use the quotient rule unless I have to. So I have the second derivative. That's what this notation means. If you're not clear, that's the derivative of the derivative, d squared dx2. The second derivative of what? The second derivative of 4 over x squared. So let me start with the derivative of 4 over x squared, which is the derivative of 4x to the negative 2. I'm going to pull the 4 out in front, which is 4 times the derivative of x to the negative 2. Let's pull that negative 2 down. 4 times negative 2x to the negative 2 minus 1, which is negative 8x to the negative 3, or if you like, negative 8 over x cubed. But I need the second derivative. So we'll take the derivative of this. So the second derivative is going to be the derivative with respect to x of negative 8x to the negative 3. And I'm going to pull out that negative 8 first. Negative 8 moves in front of the ddx operator. And I get negative 8 times the derivative with respect to x of x to the negative 3. Negative 8 times negative 3x to the negative 4. Positive 24 x to the negative 4, which is 24 over x to the 4th. It's probably how we should write the answer to that. So that's that one. That's the second derivative. Again, our question there was the second derivative of my original function, which is 4 over x squared. So you'll notice I took the first derivative and then the derivative of that to get the second derivative. That's our process there. Then we get to question C. 8 over x squared times the cube root of x. What's happening there? So we've got f of x is 8 over x squared times the cube root of x. I really don't want to use the quotient rule unless I have to. And if we know our algebra, this is 8 over x squared times x to the 1/3, and we can add those exponents. So what is that? 6/3 plus 1/3, that's 8 over x to the 7/3, which is 8x to the negative 7/3. So that's the first thing I would do with this. And then in terms of taking the derivative, f prime of x is the derivative with respect to x of 8x to the negative 7/3. We'll pull the 8 out in front of this thing, and then I get 8 times the derivative with respect to x of x to the negative 1/3. Bring the exponent down. Negative 7/3, x to the negative 7/3 minus 1. So what is that? What is negative 7/3 minus 1? Be careful with the fractions, right? Negative 7/3 minus 1 is negative 7/3 minus 3/3, or negative 10/3. So I get negative 56 over 3 times x to the negative 10/3. I would just as soon have you write this as negative 56 over 3 times x to the 10/3. Now, there's other things you could do with it. I'm perfectly fine with this answer. 10/3 is 3 1/3. So that's the same thing as negative 56 over 3x cubed, 3 1/3. You could write your answer that way, but like I said, I'm perfectly fine with that one. That's reasonable. And then we get to our last question here on this problem, which is 7x squared minus 5x plus 2 over the square root of x to find dy dx. And again, I don't want to use the quotient rule unless I have to use it. So how are we going to do that? What are we going to write on that one? So we have y equals 7x squared minus 5x plus 2 all over the square root of x. And my goal is to find dy dx. I'm going to rewrite square root of x as x to the 1/2 power. So we get y is 7x squared over x to the 1/2 power minus 5x over x to the 1/2 power plus 2 over x to the 1/2 power. And let's see, 4/2 minus 1/2, I guess that's 7x to the 3/2. That's 1 minus 1/2 minus 5x to the 1/2. In this one, that'll be 2x to the negative 1/2. All right, now what? Now we're going to take the derivative with respect to x of both sides. So the derivative with respect to x of y will be the derivative with respect to x of all of this stuff. So we get dy dx here is going to equal 7 times the derivative with respect to x of x to the 3/2 minus 5 times the derivative with respect to x of x to the 1/2 plus 2 times the derivative with respect to x of x to the negative 1/2. And what does that get me? 7 times, pull the 3/2 down, decrease the exponent by 1, 3/2 minus 1 is what, 1/2. Minus 5 times 1/2 x to the negative 1/2 plus 2 times negative 1/2 x to the negative 1/2 minus 1 negative 3/2, I believe. Correct me if I'm wrong. What does that give me? 7 times 3, 21/2. X to the 1/2 is square root of x. Minus 5 over 2x to the negative 1/2 is the square root of x downstairs. 2 times negative 1/2 is what? Is negative 1. X to the 3/2 over x to the 3/2, which is x root x, if you want to write it that way. Although, like I said, I would be okay with x to the 3/2 down there as well. So those are tedious, but they're all using the power rule. So let's remember our power rule. It's our big fact, right? The derivative with respect to x of x to the n, you pull the exponent down, n x to the n minus 1. That's our power rule. And then the derivative of the sum is the sum of the derivatives, like it was with limits. And we can pull constants out in front, again, like we could with limits. All right, let's keep on rolling. The next thing asks me for the second derivative if I am working off secant x. So if I have f of x is secant x, hopefully we know the derivatives of all of the trig functions. These should be memorized. Let's put them down here. Derivative with respect to x of sine x is cosine x. Derivative with respect to x of cosine x is minus sine x. Memorize this. Derivative with respect to x of tangent x is secant squared x. Derivative with respect to x of secant x is secant tangent, which we need to use here. Secant x is sec x tan x. Sorry, my handwriting there is not great. So f prime of x here, the derivative of secant x is sec x tan x. But what are the other ones? The derivative with respect to x of cosecant x is minus cosec x cotan x. And then the derivative of cotangent x is minus cosecant squared x. So these should be memorized. But now to get the second derivative, I'm going to need to use what? I'm going to need to use the product rule. So U is secant x, V is tangent x. U prime is sec x tan x. V prime derivative of tangent x is secant squared x. So what's my answer going to be? F double prime of x is going to be u prime v plus uv prime, our favorite product rule. U prime v, what do we get? Sec x tan x times tan x plus uv prime plus sec x sec squared x. So what is our final answer going to be? Putting all that together will be sec x tan tan, so sec x tan squared x plus sec squared, which would be plus sec cubed x. That's what the second derivative of secant would be. But please make sure you know the derivatives of the 6 trig functions. And the other things you need to memorize, of course, the derivative of natural log of x is 1 over x. And the derivative of e to the x is e to the x. So those are facts, right? That's the first thing we need to look at. So our facts as we're working through these problems. All right, that takes care of number 3 on our review as we're moving right along. And now we get to the quotient rule. So let's see what's happening there. What do I have as the quotient rule? Well, for question number 4, we want f prime of x when f of x is 2x plus 1 over x minus 3. I need u and I need v. So u is 2x plus 1. V is x minus 3 u prime, the derivative of 2x plus 1. What's the slope of 2x plus 1? 2. V prime, what's the slope of 1x minus 1? Is just 1. So f prime of x using the quotient rule is u prime v minus uv prime over v squared. Again, please correct me if I make an arithmetic mistake. U prime v 2 times x minus 3 minus uv prime 2x plus 1 times 1 all over v squared, all over v squared, all over x minus 3 squared. So where does that put us? 2x minus 6 minus 2x plus 1 over x minus 3 squared. Now I feel like I'm back in my algebra class. Got to be careful with subtraction. Change this to plus and negative and then distribute as we move along. What is that going to give me? F prime of x is 2x minus 6 plus negative 2x plus negative 1 over x minus 3 squared. 2x plus negative 2x, that goes away. Negative 6 plus negative 1 is what? Negative 7 over x minus 3 squared. So we hope that's right. We hope that's right. If not, I'm sure someone will say something. I feel pretty good about that. And then we're going to look at tangent 3x. Again, the rules on this section were to use the quotient rule. Now, we certainly have the memorized version of tangent, derivative of tangent, and we have the chain rule, which I will need to use in this problem. But to use the quotient rule to answer that, how am I going to do that? What's going to happen there? What's going to happen there? What's going to happen there? So I have y equals the tangent of 3x. Find dy dx. So we want to use the quotient rule, so we need to remember that y is sine 3x over cos 3x. And then we are ready to use the quotient rule. What is u? What is v? Where do we go from there? All right. So u is sine 3x. The derivative of the sine of something is the cos of something times the derivative of the something. So u prime is the cos of 3x times the derivative of 3x. That is our chain rule. So u prime is cos 3x times 3. So u prime is 3 cos 3x. That's my u and my u prime. My v here is cos 3x. V prime, the derivative of cosine is minus the sine of 3x times the derivative of 3x, which is 3. So v prime is minus 3 sine 3x. Okay. We want to find dy dx. U prime v minus uv prime over v squared. U prime v. 3 cos 3x times cos 3x. 3 cos 3x times cos 3x. Again, u prime v minus u v prime. Sine 3x times negative 3 sine 3x. That's negative 3 sine 3x sine 3x. All over what? All over v squared. All over cos 3x quantity squared. So this is where your trigonometry skills come in handy. So how are we going to rewrite this and simplify it using the identities that we know? Dy dx is 3 cos squared 3x plus 3 sine squared 3x over cos squared 3x. Factoring out the 3 upstairs, I get 3 times cos squared 3x plus sine squared 3x over cos squared 3x. But what do we know? Cos squared theta plus sine squared theta is 1. This is our favorite identity from trigonometry. So dy dx is 3 times 1 over cos squared 3x, which is 3 over cos squared 3x, which is 3 times 1 over cos squared 3x, which is 3 secant squared 3x, which you could have gotten immediately if you would have used the chain rule. If my directions were different, and I asked you to find the derivative of tan 3x using the chain rule, you certainly could have gotten there. So let me show you that strategy. So if we're going to do the same problem with the chain rule, the derivative with respect to x of tangent 3x. The derivative with respect to x. The derivative of the tangent something is secant squared of the something times the derivative of the something. What is my something here? My something here is 3x. So I get secant squared 3x times 3, which normally we would write as 3 times secant squared 3x. So we see that that matches what we did on the last approach, which was using the quotient rule. So clearly the chain rule is a much faster way to do it, but that requires you to have memorized that the derivative of tangent is secant squared. So you want to be sure to put all that together. All right, we have question 5, A, B, C, D, E. And I may ask you for some help with this one as I am looking at the screen. So maybe I'll pull it up. See what we have there on question 5. So here we go. We have this table of values. And I want p prime of 2. So what would that be? Well, we've got to find out what p prime of x is. So right now I have p of x is 2f of x minus 3g of x. And I want to find p prime of x. So I'm going to take the derivative of that, the derivative of 2f of x minus 3g of x. Let me show you what I'm working on here. So this is where I'm at. So the derivative of the sum is the sum of the derivatives, or the derivative of the difference is the difference of the derivatives. So p prime of x is the derivative of twice f of x minus the derivative of 3 times g of x. So p prime of x is 2 times the derivative of f of x minus 3 times the derivative of g of x. I know I'm showing every possible step. Maybe this is a little much for you. I just want to make sure I'm not leaving anything off. So p prime of x is 2 times f prime of x minus 3 times g prime of x. And you might have gotten there immediately. But I want p prime of 2. P prime of 2 is 2 times f prime of 2 minus 3 times g prime of 2. Now I've got to look at this table. F prime of 2 looks like it is 10. G prime of 2 looks like it's 4. So if that's the case, I have 20 minus 12, which is 8. So that's the process that I'm using here to work through this. All right, so let's take a look at our second question. What is that one going to say in this table? F times g of x. Q of x is f of x times g of x. I need the derivative, and that is going to require me to use what? To use the product rule. So Q of x is f of x times g of x. Now remember, the derivative of the product is not the product of the derivatives. So we're going to say u is f of x. So u prime is f prime of x. V is g of x. V is g of x. So v prime is g prime of x. And we know u v prime, product rule, is u prime v plus u v prime. So what is q prime of x? U prime v, f prime of x, g of x, plus uv prime plus f of x, g prime of x. But what did the question ask for? The question asked for q prime of 2. So if that's the case, q prime of 2 will replace all of the x's with 2's. So q prime of 2 is f prime of 2 times g of 2 plus f of 2 times g prime of 2. What do we get? F prime of 2. F prime of 2 is 10 again. We did that in the last one. Times g of 2. What is g of 2? It looks like g of 2 is 1. Plus f of 2. F of 2 looks like it's 9. Times g prime of 2. What is g prime of 2? G prime of 2 is 4. So I have q prime of 2 is 10 plus 9 times 4 is 36. Q prime of 2 is 46. As we continue with this problem, what do we have next? Next, I have f of x over g of x is my capital R, and that is going to require me to do what? That's going to require me to use the quotient rule. So let's think about that for a minute. Big R of x equals f of x over g of x. So using the quotient rule, we're going to call u f of x. We're going to call v g of x. So u prime has got to be f prime of x. And v prime's got to be g prime of x. So let's look at it. Let's look at it, see what we have. So if that's the case, what do we know again? U over v prime is u prime v minus uv prime over v squared. Fine. So what is my r prime of x? U prime v, f prime of x, g of x, minus uv prime minus f of x, g prime of x, all over v square, all over g of x square. Okay. Now, what did they want me to do with this problem? What was the idea? What we're going for? It wants r prime of 3. So I've got to go back to that last thing and replace all of the x's with 3's. So what is r prime of 3? F prime of 3, g of 3, minus f of 3, g prime of 3, all over g of 3 squared. So let's look at our table. Let's fill in those values and see what we get. R prime of 3 is what? F prime of 3. What is f prime of 3? 16 times g of 3. G of 3 looks like it's 6. Minus f of 3. F of 3 looks like it's 22. Times g prime of 3. Looks like it is also 6. All over g of 3 squared. G of 3 squared, g of 3, again, 6 squared. Pull out the calculator here for this one. What do I get? 16 times 6. Upstairs, minus 22 times 6. I get negative 36 upstairs. Over 6 squared is 36, and my result is negative 1. Just going to check that to make sure I didn't make an arithmetic mistake. Yeah, that's good. All right, so again, that required us to use the quotient rule to work through that one. And now the last two in this problem are going to require the chain rule. So let's take a look. I have f circle g of x, which means f of g of x. What is k prime of negative 2? All right, let's do this. So k of x is f of g of x. F circle g of x, which in North America means f of g of x. Now what? How do we do this? Right? If y is f of g of x, we're going to let u equal g of x. So du dx is g prime of x. Y is f of g of x, which is f of u. So dy du is f prime of u. So our derivative, dy dx, is dy du times du dx. Dy du f prime of u times du dx times g prime of x. But what is u? U is g of x, f prime of g of x times g prime of x. That is k prime of x. Using the formal version of the chain rule. What did I want here? What was the problem looking for? It's looking for k prime of negative 2. Let's do k prime of negative 2. What is k prime of negative 2? It's f prime of g of negative 2 times g prime of negative 2. What is g of negative 2? Looking at my table here, g of negative 2. It looks like g of negative 2 is 1 times g prime of negative 2. What is g prime of negative 2? It's like g prime of negative 2 is negative 4. Now, what is f prime of 1? So I've got to go ahead and do this one more time. What is f prime of 1? 1, f prime of 1. F prime of 1, f prime of 1 looks like it's 4. So 4 times negative 4, which will give me a value of what? Of negative 16. And we've got one more in this table set of problems to do. So let's go ahead and do it. Put this to the side and see what else it wants us to do. One more composition of functions, though, with this time w of x is g of f of x. So let's think about that one. W of x is G circle F of x, which is G of F of x. Okay. Maybe I'll cut to the chase a little bit this time using a less formal version of the chain rule. So what is W prime? What's the derivative of G of something, G prime of something times the derivative of the something? So it's G prime of F of x times the derivative of F of x. That's typically where we want to be with the chain rule once we're done with this unit. So W prime of x is G prime of F of x times F prime of x. Let's take a look at what they want. They want W prime of 1, okay? Replace all the x's with 1. What is W prime of 1? G prime of F of 1 times F prime of 1. What was F of 1? What is F of 1? 1. What is F of 1? It looks like F of 1 is 2. G prime of 2 times F prime of 1. What is F prime of 1? Looks like F prime of 1 is 4. So what is G prime of 2? What is G prime of 2? Looking at my table, 2, G prime of 2 also looks like it's 4. G prime of 2 is also 4. So I get 4 times 4, which is 16. So those are tedious, but I do like those problems, so make sure you're prepared for that. All right, next up, we have to do some graphical analysis. So let's take a look at this. What is F prime of 3? 3 is here. F is the top function and G is the bottom function, all right? So F prime of 3 here is what? At this point, what is the tangent, slope of the tangent? Looks like rise 1, run 1. So looking at this, I believe F prime of 3 is simply going to be 1. Slope of the tangent is always 1, so F prime of 3 is 1. Now what's the next question there? What is F prime of 1? Well, it's a sharp corner, right? On this side, it would be 1. On this side, it would be -1. So what is it at the sharp corner? F prime of 1 does not exist. At a sharp corner, F prime of 1 does not exist. And to quote Lindsay Lohan in Mean Girls, F prime of 1 does not exist. And we continue. Let K of x be F of x plus G of x. We want K prime of -1. Okay, let's look at that. K of x is F of x plus G of x. So K prime of x, the derivative of the first piece, K prime of x would be F prime of x. The derivative of the second piece, G prime of x. We want K prime of -1. So we're here. So K prime of -1 would be F prime of -1 plus G prime of -1. F prime of -1 plus G prime of -1. Let's go back and look at our picture again. F prime of -1. -1 is where is here. And the slope, F is the top function. The slope here looks like it's -1. Rise -1, run 1. Its slope is always -1. So F prime of -1 looks like -1. And then what do we need? So we have this part plus what is G prime of -1? Let's look at the graph and determine what G prime of -1 is. G prime of -1 is here. What's the slope? Rise 2, run 1. Rise 2, run 1. I guess that is going to be 2. So if that's the case, then K prime of -1 is -1 plus 2, which is positive. So we get that. Derivative of the sum is the sum of the derivatives. So that's not the most difficult thing for us to do. But what happens next? Now I have the product. So for this one, I'm going to have to use the product rule. So I have P of X is F of X times G of X. You want to find the product rule there and then use it to find P prime of negative 2. P of X is F of X times G of X. So the product rule keeps coming up. U is F of X. U prime is F prime of X. V is G of X. V prime is G prime of X. UV prime is U prime V plus UV prime. F prime of X, G of X. Plus U F of X, G prime of X. So that's my P prime of X. P prime of X will be that. P prime of X is F prime of X, G of X. Plus F of X, G prime of X. Now, what did the question ask me for? What does it want? It wants P prime of negative 2. P prime of negative 2 is F prime of negative 2 times G of negative 2 plus F of negative 2 times G prime of negative 2. Okay, let's look at our picture. So again, that's what we need. F prime of negative 2, G of negative 2 plus F of negative 2, G prime of negative 2. What is F prime of negative 2? Well, at negative 2, F is the top function, right? F prime of negative 2 here, negative 2, slope is negative 1. G of negative 2, G of negative 2, G is the bottom function, G of negative 2. If X is negative 2, the Y value here, it looks like it's negative 1. So you plug an X value in of negative 2, the value of the function is negative 1. So G of negative 2 is negative 1. Plus, what is F of negative 2? What is F of negative 2? F of negative 2 is up here. What is that? 1, 2, 3, 4, 5, 6, 7, 8. Is that what that is? I think so. F of negative 2 is 8. And what is G prime of negative 2? What is the slope here at negative 2? Again, rise. What's the slope? Rise 2, run 1. Rise 2, run 1. I guess that's 2. So again, derivative here, negative 1. Value of the function here, negative 1. Value of the function here, 8. Derivative of the function here, 2. So these are the numbers that we have. Multiply them together. I get 1 plus 16. And my answer is 17. Or the product rule in terms of looking at that table. And I think there's one more of those. Let's see what we have. G of X over F of X. So that's going to require us to do a quotient rule. So let's do that next. R of X is G of X over F of X. And I want R prime of negative 2. That's what we're looking for. Okay, let's quickly do it. U is G of X, V is F of X. It's a little strange that I wrote it that way. Let's make sure I didn't miscopy it. Yeah, G of X over F of X. Okay. So U prime, the derivative of G of X is G prime of X. V prime, the derivative of F of X is F prime of X. We know our rule, right? U over V prime is U prime V minus UV prime all over V squared. Okay. U prime V, G prime of X, F of X, minus UV prime minus G of X, F prime of X, all over V square, all over V square, all over F of X squared. That's my R prime of X, if you will. But I want R prime of negative 2, so let's plug all that stuff in. What is R prime of negative 2? That's G prime of negative 2 times F of negative 2 minus G of negative 2, F prime of negative 2, all divided by F of negative 2 squared. This is tedious. This is tedious, but let's do it. All right, looking at our picture one more time. G prime of -2. G is the bottom function. G prime of -2. Derivative here, slope here is what? Rise 2, run 1. G prime of -2 is 2. What is f of -2? The value of the function is not the slope, but just the value of the function. When f is -2, the value of the function is 8. -2, 8. So g prime of -2 is 2. F of -2 is 8. What do we need next? Now I need minus g of -2 minus f prime of -2. So what is g of -2? G is the bottom function. What is g of -2? I guess it's -1. What is f prime of -2? F prime of -2, what is the slope here? Slope here at -2, down 1 over 1. Slope is also -1, so the derivative there is -1. Over f of -2 squared, what did we say f of -2 was? -2 up there is 8, f of -2 is 8 over 8 squared. So I get 16 minus 1 over 64, which is 15/64 is what that turns out to be. Challenging problems, really making you think about what the derivative means, thinking about it as a slope. All right, where does that take us? Now we are ready to talk about velocity and acceleration and find values where the velocity is 0. Great. So let's do that here on number 7. So my position function s of t is 3 sine 2t. S of t is 3 sine 2t. I want the velocity and I want the acceleration. The velocity is the derivative of position. So velocity, v of t, is the same as s prime of t, which is the derivative with respect to t of 3 times sine 2t. We pull the 3 out in front. So v of t is 3 times the derivative with respect to t of sine 2t. Well, the derivative of the sine of something is cos of something times the derivative of the something. So I get 3 times the cosine of 2t times the derivative with respect to t of 2t. So v of t is 3 times cos 2t times 2, and v of t is 6 cos 2t. All right, very good. And then we want acceleration. Acceleration is the derivative of velocity. Acceleration, a of t, is v prime of t, or if you like, s double prime of t. So acceleration will be the derivative of the velocity. So acceleration, a of t, is the derivative with respect to t of v of t, which is the derivative with respect to t of 6 times cosine 2t. We pull the 6 out in front. So it's 6 times the derivative of cos 2t. The derivative of the cos of something is minus the sine of something times the derivative of the something. The derivative of 2t is just 2. So we get acceleration is 6 times 2 times -1, -12 sine 2t. Is our acceleration. But then what else did the question ask there? Then it wants the values where the velocity equals 0, between 0 and 2 pi. So when does the velocity equal 0? This takes us back to our first test when we were working with trigonometric equations. So I need to solve when does 6 times cosine of 2t equals 0. So let's do that. P of t equals 0. So 6 cos 2t equals 0, which means that cos 2t equals 0. You divide by 6. Let theta equal 2t. But I am solving cosine of theta equals 0. When does cosine equal 0? Cosine is when the x values on the unit circle are 0. So notice this is the point 1, 0. This is the point 0, 1. This is the point -1, 0. This is the point 0, -1. When are the x values 0 here and here? Here the x value is 0. Here the x value is 0. What is this? 90 degrees or pi over 2. And 270 degrees or 3 pi over 2. So what I will say is theta is pi over 2 or theta is 3 pi over 2. But what was theta? Theta was 2t. 2t is pi over 2. 2t is 3 pi over 2. Dividing by 2 or multiplying both sides by a half. Multiply both sides by a half. I get t is pi over 4. Multiply both sides by a half, t is 3 pi over 4. But that's not all of them. That's 2 answers. But there's actually 4 answers to this question in the interval from 0 to 2 pi. What else do I have to say? I've got to say theta is pi over 2 plus 2 pi. That would go all the way around and back. So that's theta is 5 pi over 2. Also, theta is 3 pi over 2 plus 2 pi, which theta is 7 pi over 2. Theta is 2t. 2t is 5 pi over 2, so t is 5 pi over 4. Notice it's still between 0 and 2 pi. 2t is 7 pi over 2, so t is 7 pi over 4. So those are the other 2 answers that we get. 4 answers to the question when velocity is 0 on the interval from 0 to 2 pi. And we continue with number 8.
Professor.
What do we have there? Again, if you have questions, feel free to stop me, write in chat, or speak out loud. I do have a new message.
Yeah, Professor, can you hear me?
I can.
Oh, okay, great. Yeah, for 7a and 7b, it says determine velocity at pi over 6.
So maybe I didn't do that. All right, let's finish it. Maybe I didn't finish that. So what did we have? We had
we just determined that it's 6 cosine
right,
2t.
right. I missed that. So the velocity of t was 6 cosine 2t. And the acceleration was what? As I look back on my pages, the acceleration was -12 sine 2t. Thank you very much for that. And the question asks us, they wanted it pi over 6, is that right? Yes, indeed. So velocity at pi over 6 and acceleration at pi over 6. Thank you. What is the velocity at pi over 6? It's 6 times the cosine of 2 times pi over 6. So the velocity at pi over 6 is 6 times the cosine of pi over 3. Now, hopefully you know your basic trig functions, right? Cosine of pi over 3 is the same as sine of pi over 6, which is 1/2. So the velocity at pi over 6 is 6 times 1/2. The velocity at pi over 6 is 3. Over here for acceleration, plugging in pi over 6. The acceleration for pi over 6 is -12 times the sine of 2 times pi over 6. So the acceleration at pi over 6 is -12 times the sine of what? Of pi over 3, which is √3 over 2. A of pi over 6 is -12 times √3 over 2. -12 over 2 is -6. Acceleration at pi over 6 is -6 √3. So yeah, please memorize your basic trig angles. 30 degrees, which is pi over 6, 60 degrees, which is pi over 3, for sine, cosine, And then you can build all the others as you go. All right, good deal. Thank you for the correction there. I appreciate that. Let us move on to number 8.
Thank you, Professor.
Thank you. Number 8, what do we have? Use the rules of derivatives to do that. Okay, well, again, you've memorized the derivatives of the 6 trig functions. So I want to look at the limit as h goes to 0 of secant x plus h minus secant x over h. All that is, we recognize that from our formula, that's just the derivative of secant x, and the answer to that is sec x tangent x. That's it. I just wanted you to recognize that fact. Okay. Recognize that the limit definition, now we can immediately go to our shortcut strategies and get our answer that way. So that's all I wanted on 8. Then we get to number 9, which is the dy du dx stuff of the chain rule. So let's take a look at all of that. All of that great stuff. What are we going to have? Number 9, I have ddx of x squared minus 8x plus 3 to the 24th power. So y equals that stuff, x squared minus 8x plus 3 to the 24th power. So dy dx will be dy du times du dx. What is u? U will be the inside function. U is x squared minus 8x plus 3. So du dx is 2x minus 8. Okay. What is y? Y is u to the 24th. So the derivative of y with respect to u is 24u to the 23. Can't see any of that. Let me go ahead and show you all that. So again, ddx x squared minus 8x plus 3 to the 24th power. So I'm calling that y. I'm saying y is x squared minus 8x plus 3 to the 24th power. And I'm saying dy dx is dy du times du dx. U is the inside function. U is x squared minus 8x plus 3. Du dx derivative 2x minus 8. Y is u to the 24th. So dy du is 24u to the 23rd. Now we're ready to make our substitutions. dy du 24 u to the 23rd times du dx times 2x minus 8. What was u? U was x squared minus 8x plus 3 to the 23rd. And I am perfectly fine with you leaving it like this. You might want to distribute here. I don't need you to do that. For me, I'm perfectly satisfied with that answer. All right, next up, number 9. We have f of x is 1 over the square root . 3x squared plus 11. So u is going to equal, I don't know what u is going to equal. We have kind of a, let's rewrite it this way as 1 over 3x squared plus 11 to the 1/2 power, which is 3x squared plus 11 to the negative 1/2 power. There we go. That's what we want. So y will equal 3x squared plus 11 to the negative 1/2. So u is 3x squared plus 11. Du dx is 6x. Y is u to the negative 1/2. Dy du is negative 1/2 u to the negative 3/2. So what do we typically say? So that's negative 1 over 2 u to the 3/2. Then we say dy dx equals dy du times du dx, dy du, which is this, -1/2 times u to the 3/2 times du dx. Du dx is what? Just 6x, which is -6x/2. What was u? What was u? What was u? 3x squared plus 11. And I get -3/3x squared plus 11 to the 3/2. That's what happens to that one. Again, we're being very, very formal with the chain rule just to kind of make sure that we cement the idea. Now, the next question I have is cosine cubed of x. Why is cosine cubed of x? That notation always confuses students here. That means cos x to the 3rd power. That's what that notation means. So u is cos x, du dx is negative sine x. Y is u to the 3rd, dy du is 3u squared. Then what do we say? Dy dx is dy du times du dx. Dy du, 3u squared times du dx times cos x. What the heck is u? What the heck is u? U is cos x. Three times cos x squared. No, du dx wasn't cos x. What was du dx? Du dx was negative sine x. Corrected. There you go. 3u squared times du dx times negative sine x. How do we usually write this? -3 cos squared x times sine x. That's what that one. Remember, we're still trying to use the chain rule on these things. So when I get to 9D, let's take a look at it. It's cosecant x. So how do I use the chain rule for cosecant x? The derivative with respect to x of cosecant x, which is the derivative with respect to x of 1 over sine x, which is the derivative with respect to x of sine x to the -1 power. That's what I'm going to need to use. So let's call that y. Let's say y is sine x to the -1. U is sine x. So du dx, the derivative of sine x is cos x. Y is u to the -1, so dy du is -1 u to the -2. Dy du is -1 over u squared. Then where do we go? Then what do we say? Then we say dy dx is dy du times du dx. Dy du, -1 over u squared times du dx times cos x. What was u? What was u? What was u? U was sine x. So negative cos x upstairs, sine x times sine x downstairs, sine x squared times sine x times sine x, which is -1 over sine x times cos x over sine x. And there you recognize what we've memorized before. It's negative cosec x cotangent x. Or our basic rules of trigonometry. So we're also able to do it that way, which is nice. We've got one more of these formal chain rule things showing up here. 9e, which is x over x plus 3 to the 7th power. Let's do it. Let's do it as we think about the chain rule. The chain rule really is the most important concept on this unit. G of x is x over x plus 3 to the 7. So we're going to say y is that. Y is x over x plus 3 to the 7th. U is x over x plus 3. So y is u to the 7th So dy du is 7u to the 6th, but du dx is going to require us to use the quotient rule. So let's change up colors. Green u is x, green v is x plus 3, green u prime is 1, green v prime is 1, green u over green v prime is u prime v minus uv prime over v squared. What do I get? U prime v 1 times x plus 3 minus uv prime minus x times 1 all over v squared. What was v? What was v? X plus 3 squared. So I get x plus 3 minus x over x plus 3 squared, which is 3 over x plus 3 squared. That is my du dx. So up here, du dx is what I just did, 3 over x plus 3 squared. Hope I did that right. We'll take a quick look at it one more time. Yeah, I think so. All right, and then let's finish this off. How do we finish this off? Dy dx, g prime of x is the same as dy dx, which is dy du times du dx. Dy du, what do we say dy du was? 7u to the 6th times du dx, we said 3 over x plus 3 squared. What is u? U was x over x plus 3 all raised to the 6th power. 7 u to the 6th x over x plus 3 to the 6th power times 3 over x plus 3 to the 2nd power. That answer is pretty good. I guess we should multiply 7 times 3 is 21. I guess x to the 6th probably should be there. And I have x plus 3 to the 6th and x plus 3 to the 2nd. Downstairs, I guess that would be x plus 3 to the 8th power. I hope that's right. You can say if not, but I think it is. X plus 3 to the 6th, x plus 3 to the 2nd, x plus 3 to the 8th, 7 times 3, 21, x to the 6th. I think that's good. So that's tedious. Logarithmic differentiation might have made that a little easier. That's another thought as we're moving through it. All right, now let's do the faster version of the chain rule because we're sick of doing the slow version of the chain rule. So question 10, we just kind of peel these things off as we go and see where they head. So let's do that next. Question 10. I have the derivative of the tangent of 7x. How do we do this? The derivative of the tangent of something is secant squared of something times the derivative of the something. So secant squared of 7x times the derivative of 7x, which is secant squared 7x times 7, or 7 secant squared 7x. Good, 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 good. Next. We have the derivative of the sine of something. The sine of 3x plus 1 to the 2nd power. The derivative of the sine of something is the cos of something times the derivative of the something. Okay, so it's the cosine of 3x plus 1 squared times the derivative of 3x plus 1 squared, which gives me the cosine. What's the derivative of something squared? 2 times something to the 1st times the derivative of the something. So that's 2 times 3x plus 1 to the 1st times the derivative of 3x plus 1. Where does that give me? Cosine 3x plus 1 squared times 2 times 3x plus 1 times 3. And frankly, I'm almost happy with this answer. But maybe we should multiply the 2 times 3 is 6, and then the 3x plus 1. You could multiply that if you want. I don't care very much. And then the cosine. 3x plus 1 squared as we peel these things as we move through them. So yeah, there is no one right way to write the answer, which is why if you check on Photomath or Symbol Lab, oftentimes it's going to be hard for you to convince yourself that you've done it correctly, which is why I really prefer the calculator as a tool to check your work. Next, y is 1 over 6x plus 1 to the 8th. Which we're going to write as 6x plus 1 to the negative 8th. So dy dx is the derivative with respect to x of 6x plus 1 to the negative 8. What is that? Negative 8. 6x plus 1 to the negative 9 times the derivative negative 8 times 1 over 6x plus 1 to the 9th times 6, negative 48 over 6x plus 1 to the 9th. Good enough. And then the last one in that set of problems is sine to the 4th power of 9x. Again, we're going to peel this as we work through it. Peel all these various pieces off. So what do I have? What do I have? What do I have? What do I have? I have the derivative with respect to x of sine to the 4th of 9x. What does that mean? The derivative of sine 9x to the 4th power. The derivative of something to the 4th power. 4 times something to the 3rd times the derivative of the something. What is the something? Sine 9x. Sine 9x. What does this mean? 4 times sine cubed 9x times, what's the derivative of sine of something? Cos of something times the derivative of the something. Cos of 9x times the derivative of 9x. Where does that send me? 4 sine cubed 9x times cos 9x times 9. Probably multiply the 4 times the 9 to give me 36. Sine cubed 9x cos 9x. That knocks out that. All right. So that's it for our discussion on chain rule, although notice the next problem is going to have a different version with exponential functions rather than trig functions. So on number 11, I have the derivative of e to the 9x. The derivative of e to the something, remember the derivative of e to the x is e to the x. Let's not forget that. The derivative of e to the x is e to the x. So the derivative of e to the something is e to the something times the derivative of the something. What's the something here? 9x. So it's e to the 9x times 9, which we normally write as 9 e to the 9x. The next problem, though, is going to require us to use the product rule. So good reminder of that one. I have f of x is 3x to the 5th, e to the 2x. So let's play with u's and v's. So u is 3x to the 5th, v is e to the 2x, u prime is 3 times 5x to the 4th, u prime 15x to the 4th. V prime, the derivative of e to the something is e to the something times the derivative of the something. So it's e to the 2x times the derivative of 2x. V prime is e to the 2x times 2. V prime is 2e to the 2x. So we've done the product rule hopefully successfully. So f prime of x is u prime v plus uv prime. U prime v, 15x to the 4th times e to the 2x plus uv prime plus 3x to the 5th times 2e to the 2x. I guess we should multiply 3 times 2, make that a little prettier. 15x to the 4th, e to the 2x plus 6 x to the fifth e to the 2x, e to the 2x. I guess that's right. 15x to the fourth e to the 2x plus 6x to the fifth e to 2x. Yeah, I think that's right. Then we have one more in this set of problems. Take a quick look at that one. Find dy dx when y is e to the sine of 2x. So what is dy dx? The derivative of e to the something is e to the something times the derivative of the something. As we keep doing chain rule over and over and over again, kind of important. Like I said, maybe the most important thing in the class. So e to the sine 2x. The derivative of sine 2x is cosine of 2x times derivative of the inside times 2. Final answer 2e to the sine 2x times cosine of 2x. And that takes us to the end of that problem, which now brings us to implicit derivatives. So let's look at how that behaves. What do we have next? This gets challenging with the computation, with the procedural work here. X squared y plus xy cubed equals 10. We want to find dy dx. That's one of our goals here. So take the derivative with respect to x of the first piece, the derivative with respect to x of the second piece equals the derivative with respect to x of the third piece. The derivative with respect to x of x squared y plus the derivative with respect to x of xy cubed equals the derivative with respect to x of 10. Then what do we have to do? We've got to do a whole bunch of product rule stuff. So let me get a different sheet of paper and let's do that. So for the first one, for the first piece, u is x squared, v is y, u prime is the derivative with respect to x of x squared, v prime is the derivative with respect to x of y, u prime is 2x, v prime is dy dx. What's our rule? uv prime is u prime v plus uv prime. What do we get? U prime v 2xy plus x squared dy dx. That's my first piece. Okay. That's my first piece. That's the derivative with respect to x of x squared y. Let's put that in there. 2xy plus x squared dy dx. Now this next piece I need to do again is xy cubed. How is that going to work? U is x, v is y cubed. U prime is the derivative with respect to x of x. U prime is 1. V prime is the derivative with respect to x of y cubed. What's the derivative of something to the third power? 3 times the something to the second power times the derivative of the something, but this time the something is y. So I get 3y squared times dy dx. So what's my result here? uv prime is u prime v plus uv prime u prime v, which is what y cubed, plus uv prime plus x times 3y squared dy dx. Let's write all that down. Plus y cubed. Plus, I'm going to write that as 3xy squared dy dx. The derivative with respect to x of 10 is 0 because that is a constant. All right. Now we've got to solve for dy dx. So move the stuff that's not dy dx to the other side. He moves to the other side. He moves to the other side. So on the left side, I have x squared dy dx plus 3x y squared dy dx. He moves to the other side, becomes negative 2xy. He moves to the other side, becomes minus y cubed. Factor out the dy dx on the left side. And I get x squared plus 3x y squared equals negative 2xy minus y cubed. Divide that stuff out on both sides. X squared plus 3xy squared. X squared plus 3xy squared, and I get dy dx is negative 2xy minus y cubed over x squared plus 3xy squared. Now I want to find the slope at 1, 2. So if I plug 1, 2 in, what am I going to get? Slope at 1, 2. dy dx equals negative 2 times 1 times 2 minus 2 cubed over 1 squared plus 3 times 1 times 2 squared. Well, that's messy. What does that give me? Upstairs, negative 4 minus 8, negative 12 upstairs. Downstairs, 4 times 3 is 12, plus 1 is 13, negative 12 thirteenths. And then the last thing I want is I want the equation of the tangent line at 1, 2. Okay, well, if the slope is negative 12 thirteenths, and the point is 1, 2, I hope that slope is right. Slope is negative 12 thirteenths. And the point is 1, 2. Use point slope form. Y minus y1 equals m times x minus x1. So y minus 2 equals m negative 12 thirteenths x minus 1. Good enough. That's the equation of that tangent. All right. What is next? Now we have some of my favorite problems here at the end of this assignment. Let us finish these off. So I want to take the derivative of the inverse sine of 5x. The derivative with respect to x of the inverse sine of 5x. How do we do this? We're going to say y is the inverse sine of 5x. So sine of y equals 5x. That's the first thing you've got to remember. Sine of y is 5x. Then we take the derivative with respect to x of both sides. The derivative with respect to sine y is the derivative with respect to x of 5x. Now, the derivative of the sine of y is cosine of y, dy dx. Derivative of sine of something is cos of something times the derivative of the something. So cos of y times the derivative with respect to x of y times dy dx equals that. And then dividing both sides by cos y, I get dy dx is 5 over cos y, but I'm not finished. I'm not finished. So I need to go ahead and do a triangle. So let's go ahead and do that. How do I do that triangle? What's the idea? I recognize sine of y is 5x over 1, which is opposite over hypotenuse. And draw a triangle. Opposite 5x, hypotenuse is 1. So the base here is the one I got to find, but I'm going to use Pythagoras. Pythagoras, a squared plus b squared is c squared. So 5x squared plus b squared is 1 squared. 25x squared plus b squared is 1. B squared is 1 minus 25x squared. B then is the square root of 1 minus 25x squared. So looking at this, cosine of y is adjacent over hypotenuse. Adjacent is here, right? Adjacent to y, root 1 minus 25x squared over 1. So cosine of y is root 21 minus 25x squared. So here we go. We have dy dx is 5 over root 1 minus 25x squared. And that is my inverse sine of 5x antiderivative. And then the other question is inverse secant of 3x, done exactly the same way. So we need to go ahead and figure that out. So we're going to think about triangles again. What's going to happen there? What are we going to say? We have y is inverse secant of 3x. So secant of y equals 3x. Let's take the derivative of both sides. The derivative with respect to x of sec y is the derivative with respect to x of 3x. The derivative of secant y tangent y, dy dx equals 3. So dy dx equals 3 over sec y tangent y. Well, I know what sec y is. Sec y is 3x. We have that. That's done for us. So I have dy dx is 3 over 3x tangent y. Now, how am I going to get tangent y? Here's the argument. Sec y is 3x. Reciprocal then cos of y is 1 over 3x, which is adjacent over hypotenuse. Let's draw the triangle. Adjacent over the hypotenuse. Got to go ahead and I've got to find b again. So a squared plus b squared is c squared. 1 squared plus b squared is 3x squared. 1 plus b squared is 9x squared. B squared is 9x squared minus 1. B is the square root of 9x squared minus 1. Now looking at this then, what's tangent? Opposite over adjacent. Do you see tangent of y? I guess that's a y here, not a theta. Tangent of y is root 9x squared minus 1. 3 over 3x root 9x squared minus 1. Obviously the 3's divide out. 3 divides out, boom, boom, and I get 1 over x. Root 9x squared minus 1. All right. Which brings us to another implicit derivative kind of thing that we're going to work on. As we're hitting the 8 o'clock hour. This one a little long. Sorry about that, my friend, but I'm glad you're still with me. Many of you are still with me. So the next one we have is x squared minus 4y squared equals 36. We will take the derivative with respect to x of both sides. So the derivative with respect to x of x squared minus the derivative with respect to x of 4y squared is the derivative with respect to x of 36. So this first piece is 2x minus 4 times the derivative with respect to x of y squared equals the derivative of 36. The derivative of a constant is 0. And we continue, 2x minus 4. The derivative of something squared, 2 times the something to the first times the derivative of the something equals 0. But the something here is y. So I get 2x minus 8y dy dx equals 0. So 2x equals 8y dy dx. Then we divide both sides by 8y. So I get x over 4y equals dy dx. X over 4y equals dy dx. Now, I want to get the second derivative. So let's move on to that question. So I've got dy dx is x over 4y. So u is x, v is 4y, u prime is the derivative with respect to x of x, v prime is the derivative with respect to x of 4y. So u prime is 1, v prime is 4 times dy dx, but we know what dy dx is. V prime is 4 times x over 4y. So v prime is, the 4's to divide out is just x over y. Okay. What are we going to do with this? So the second derivative, v2y dx2 is u prime v minus uv prime over v squared. What do I get? U prime v, 1 times 4y, minus uv prime minus x times x over y, all divided by v squared, all divided by 4y squared, which gives me 4y minus x squared over y, all divided by 16y squared. Now to make this prettier, I'm going to multiply top and bottom by y. Multiply the top by y, multiply the bottom by y. Then what do I get? Then I get 4y squared minus x squared over 16y cubed, which is a perfectly good answer, except remember, we were told in the beginning that x squared minus 4y squared was 36. So 4y squared minus x squared would be negative 36. And then what can we divide by? Divide by 4, right? Negative 36 divided by 4, negative 9 over what? Over 4y cubed. So that's tricky. That is definitely a trickier problem than a lot of them. But again, I will likely give you credit for this, although that is a better answer. If you can recognize that what they gave me here, x squared minus 4y squared is 36. So multiplying both sides by -1, negative x squared plus 4y squared is negative 36, or 4y squared minus x squared is negative 36. See how that was able to work. All right. To number 15. And we have the derivative of the log of 5x. So we're just kind of reinforcing the log rules here. What do we have there? Derivative of log of 5x. The derivative of the log of something is 1 over the something times the derivative of the something. So the derivative of log of 5x, 1 over 5x times the derivative of 5x, which is 1 over 5x times 5, which is 1 over x. Boom, nice. The next example I have is I want the derivative of 2x times the natural log of x squared plus 8. And this is going to require us to do what? To use the product rule. So u is 2x. So that would make u prime 2. V is log x squared plus 8. V prime is 1 over x squared plus 8 times the derivative of x squared plus 8, which is 2x. So v prime is 2x over x squared plus 8. And then what do we get? What's our answer going to be? U prime v plus uv prime. U prime v twice. Log x squared plus 8, u prime v plus uv prime plus 2x times 2x over x squared plus 8. What do I get? I get twice the log plus 4x squared over x squared plus 8. That's what we get there. Then I've got one more to do here. 15 is going to be a chain rule-ish problem. Let's take a look at how that's going to work. So I've got y is the log of the cos of 7x. What is dy dx? The derivative of the log of something, 1 over the something, times the derivative of the something. 1 over cos 7x. What's the derivative of cos of something minus the sine of something times the derivative of the something? The something this time is 7x. So I get dy dx is 1 over cos of 7x times negative sine 7x times 7. How should we write that? A little cleaner. Negative 7 sine 7x over cos 7x, which if you'd like, you could call it negative 7 tangent 7x. That's an option there. Which finally, after an hour and a half, brings us to our last page. Okay, all logarithmic differentiation. Let's do it and let's be done so you can get back to your studying. Here we go. The derivative of 8 to the x. How do I do that? I let y equal 8 to the x. My goal is to find dy dx. Zap both sides of the natural logarithm. Natural log y is natural log 8 to the x. Take the derivative with respect to x of natural log y. I'm going to pull this x down front here, which is x log 8 first. I guess I should have said that. We'll take the derivative with respect to x of x log 8. I don't like the fact that I jammed that, so we'll start it again. Pull the 8 down. Natural log y is x times natural log 8. Then take the derivative with respect to x of both sides. Derivative with respect to x of log y is derivative with respect to x of x times log 8. Now, what is the derivative of log y? 1 over y times the derivative with respect to x of y. 1 over y dy dx. The derivative of x times log 8 is log 8. Multiply both sides by y. Dy dx is y times log 8, which is what? Which is 8 to the x power times log 8. And then the next one is done the same stinking way. Let's do the next problem, which is f of x is log base 3 of x. How do we do this one? F of x is log base 3 of x. I call it y equals log base 3 of x. And our goal, again, is to find dy dx. So 3 to the y equals x, using our rule of logs. Take the natural log of both sides. Natural log of 3 to the y equals natural log of x. Pull the y down in front. Y times natural log 3 equals natural log x. At this point, I can take the derivative with respect to x of both sides. The derivative of y times log 3 is the derivative of log x, but log 3 is a constant. It comes out in front. So I get log 3 times the derivative with respect to x of y. The derivative of log x is 1 over x. The derivative with respect to x of y is dy dx. Log 3 dy dx equals 1 over x. Divide both sides by log 3. What does that give me? Dy dx is 1 over x times log 3. Good. And now we get the real fun problems with logarithmic differentiation. So let's do it. 16c, pretty nasty, but we'll do our best here. We have y equals 2x squared plus 5 to the 7th power. Then it says sine to the 3rd, which I'm going to rewrite as sine of 4x to the 3rd power all over square root of x plus 3, which I'm going to rewrite as x plus 3 to the 1/2. Step 1, zap with a log. So log of y equals log of all of that stuff. The log of the quotient is the difference of the logs, log of the top minus log of the bottom. So log of the top, 2x squared plus 5 to the 7th times sine 4x to the third. And we know we're going to eventually make that a sum. Minus log at the bottom. So that's the sum. The log of the product is the sum of the logs. So next line, log of this is log 2x squared plus 5 to the 7th plus log sine 4x to the third minus log x plus 3 to the 1/2. Then we can also pull the exponents down. That's my next move. Log y equals 2 times the log of 2x squared plus 5 plus 3 times the log of sine of 4x minus 1/2 the log of x plus 3. Then what? Then we take the derivatives. So how is that going to work? We'll take the derivative with respect to x of log y equals twice the derivative with respect to x of log 2x squared plus 5 plus 3 times the derivative with respect to x of the log of sine of 4x minus 1/2 times the derivative with respect to x of the log of x plus 3. The derivative of log y, 1 over y times the derivative with respect to x of y, dy dx, equals 2 times the derivative of log of something, 1 over the something, times his derivative. What's the derivative of 2x squared plus 5, 4x, plus 3 times the derivative of the log of something, 1 over the something, 1 over the sine of 4x. What's the derivative of the sine of something, cos of 4x, times the derivative of the something, times 4. Minus 1/2 the derivative of the log of x plus 3. 1 over x plus 3, the derivative of x plus 3 is just 1. What do we have? 1 over y, dy dx. 2 times 4x, 8x over 2x squared plus 5. Plus 4 times 3 is 12. Cos 4x over sine 4x, let's call it cotangent 4x. Minus 1 over 2. Multiply both sides by y. Multiply both sides by y, so y times all this. And then finally replace y in your final stinking answer. So what was y all the way back in the beginning? What was y? What was y? Y was this. So we can write our final answer as dy dx equals all of that times all of that. Dy dx equals 2x squared plus 5 to the 7th, sine cubed of 4x. Go back to the other notation, over the square root of x plus 3, multiplied by all of that stuff, 8x over 2x squared plus 5, plus 12 cotangent 4x, minus 1 over 2 times x plus 3. So as miserable as that is, logarithmic differentiation makes that a little bit more manageable. Okay, just two more questions.
Quick.
Yes.
For the test, we have to write it out like that, or could we get could we put y?
No, you got to write. You have to sub the y back. Yeah.
All right.
But I'm not going to make you distribute. Good enough. Yeah, we created y. Y wasn't part of the original problem. So yeah, you should really write it down. All right. Two more stinking questions at 8:15. We're past our usual class time of 1:45. Here we go. Cos 6x to the x. Y equals cos 6x to the x. Zap both sides with the log. Log y is log cos 6x to the x. Pull the x down in front. Log y equals x times the log of cos 6x. Take the derivative with respect to x of both sides. The derivative with respect to x of log y is the derivative with respect to x of x times the log of cos 6x. This is 1 over y dy dx, and this requires the what? This requires the product rule. U is x, u prime is 1. V is the log of cos of 6x. What's the derivative of the log of something? 1 over cos of 6x times the derivative of cos of 6x, which is negative sine of 6x times 6. So v prime is negative 6 sine 6x over cos 6x. V prime is negative 6 tangent 6x. Okay, u prime v, 1 times, let's make sure we're not bleeding in. U prime v, 1 times log cos 6x, log cos 6x, plus uv prime x times negative 6, that'll be negative 6x tan 6x. Multiply both sides by y. dy dx is y times log cos 6x minus, actually not this third one, minus 6x tan 6x, and then finally multiply, show your answer, multiplying into y. Dy dx is cos 6x to the x times log cos 6x minus 6x tan 6x. Whew. And the last final problem after an hour and 20 minutes is, or hour and 40 minutes, f of x is x to the 1 over x. Let's do it. F of x is x to the 1 over x. So 1 over x. Y is x to the 1 over x. Log y is log x to the 1 over x. The derivative with respect to x of log y, nope, not yet. Pull the 1 over x down. Log y is 1 over x log x. Now take the derivative. Derivative with respect to x of log y is derivative with respect to x of log x over x. Okay. 1 over y dy dx here. I've got to do quotient rule. So u is log x, v is x. U prime derivative of log x is 1 over x, v prime is 1. U prime v, 1 over x times x, plus uv prime, plus log x. Nope, wrong. Okay, I guess I'm getting excited, I'm almost done. Let's try this again. It's u prime v minus uv prime over v squared. 1 over y dy dx, we're using the quotient rule. U prime v, 1 over x times x, that's 1, minus uv prime minus log x, all over v squared, all over x squared. So dy dx equals y times 1 minus log x. What is y? Y is x to the 1 over x. One minus log x over x squared. And that, my friends, is that. Wow. So a lot going on there. So our test tomorrow is obviously not this long. I think there's 14 questions on it, but not with all of these multiple parts. So we made it a little bit more manageable. I don't think you'll have any trouble getting it done in the hour 45. If you want to start a little early or stay a little late, that's always fine too. All right. Any questions for me before we shut down our recording? I don't blame you.
No, sir.
That was a lot. Yes, sir.
Thank you very much.
All right. Good enough, folks.
Have a good
That was
night.
exhausting. I will do my best to post this on YouTube if you want to watch it again or quickly zip through it. I'll try to get that done before the end of the evening. All right, my friends. Well, I've got an appointment here that I'm a little late for, so I'm going to let you go. But I will see you tomorrow. Thanks for coming in.
Thank you. See you tomorrow.